Ayubowan everyone, and a very warm welcome to Study Hub Sri Lanka. Today, we're going to dive into a really important concept from your Grade 10 science syllabus, resultant force. Now, I know it sounds a bit technical, but trust me, by the end of our session today, you'll understand it perfectly. All right, let's get started, shall we?
So imagine this scene. We've all seen it, right? A car has stalled on the road. Now this one person is trying their best, pushing with all their might. They're applying a force, but the car is just too heavy and doesn't want to move. It's a real struggle. One person's force just isn't enough.
But then, look what happens when a few friends come to help. They all push together in the same direction, and suddenly the car starts to move. It's much easier now. So the big question is, why? What's the secret here? How does combining all those small pushes make such a big difference?
Well, that question is exactly what we're going to answer today. It leads us straight to the main idea of this lesson, a fundamental principle in physics that explains how different forces can act together. And here it is. The secret has a name. It's called the resultant force. You see, the resultant force is the single overall force that has the exact same effect as all the other individual forces combined. It's like taking all those separate little pushes on the car and trading them in for one big, effective super push.
Okay, so let's break this down. We'll start with the simplest situation. Case number 1. What happens when all the forces are pushing or pulling in the very same direction?
This is a perfect real-world example. Think about these fishermen pulling in a big, heavy net. Each person is pulling with their own strength, but because they're all pulling together in the same direction, their efforts combine. And in physics, it's just that simple. When forces work together like this, you just add them up.
All right, let's try an example with some numbers so you can see how it works. Imagine there's a box. One child pulls it with a force of 8 newtons. Then, another child comes to help and pulls in the same direction with a force of 6 newtons. So, to find the total force, or the resultant force, what do you think we do? That's right, it's just simple addition. We take the 8 newtons from the first child, and we add the 6 newtons from the second child. And that gives us a total resultant force of 14 newtons. And very importantly, the force acts in the same direction they were both pulling. See? That's all there is to it.
Right, so adding forces is easy when everyone is working together. But what happens when the forces are, well, fighting against each other? This brings us to case number 2, forces acting in opposite directions.
You can see the difference so clearly here. On the one side, you have forces cooperating, building each other up. But on the other side, you have forces opposing each other, working against one another. And as you can guess, this leads to a very, very different result. And the best example for this is a game of tug-of-war. Of course, you have one team pulling with all their might in one direction and the other team pulling just as hard in the opposite direction. Now, to find the resultant force here, you don't add, no, you find the difference. You just subtract the smaller force from the larger one.
So, which way is the rope going to move? Well, it's common sense, isn't it? The rope will move in the direction of the stronger team, the team that's pulling with the larger force. And that's the simple rule to remember for the direction.
Okay, now let's look at a small variation of this that you will definitely come across. So far, the forces we looked at were acting along the same single line. But what happens if the forces are parallel?
Now don't worry, the word parallel shouldn't scare you. It's actually very simple. It just means that the forces are acting in the same direction, but at different points on the object. Let's go back to our car. Imagine one person is pushing on the left side of the car and another person is pushing on the right side. You are both pushing forward, right? So your forces are parallel. And here is the best news. The rule for calculating the resultant force is exactly the same as our very first case. You just add the forces together. So if forces are parallel and going in the same direction, the resultant force is just their sum. Simple as that. We've covered the main ideas now. So to make sure all of this really sticks in your mind,
especially for your exams. Let's do a quick summary of the key rules.
This little table right here is going to be your best friend for revision, so pay close attention. It all comes down to one simple question. Are the forces working together or are they competing? If they're in the same direction, you add them, and the resultant force goes in that same direction. If they are in opposite directions, you subtract the smaller one from the bigger one, and the resultant force goes in the direction of the stronger force.
So let's quickly go over the key takeaways. 1. Resultant force is the combined overall effect. 2. For forces in the same direction, you add. 3. For forces in the opposite direction, you subtract. If you can master these simple rules, you have mastered the basics of this topic.
Okay, now it's your turn. The absolute best way to make sure you understand this properly is to practice. So please, take out your textbook, find the exercises on resultant force, and try to apply what we've learned here today. That's how it will really stick.
And if you found this lesson helpful, it would mean the world to us if you could do a small favor and subscribe to our channel, Study Hub Sri Lanka. And please, don't forget to click that little bell icon next to it so you'll get a notification the moment we upload our next lesson.
Thank you so much for joining me for this lesson today. I really hope it was helpful for you. We will meet again very soon with another science lesson. Until then, good luck with all your studies.